All right, hello everyone. If you were absent or need help with this packet 4 for the functions class, this is the video for you. We're gonna go ahead and start with part 1 and we're just gonna zip right through. One of the things that I wanna talk about is that in this chapter, we're gonna be thinking a lot about visualizing and being able to see things in our mind to help us through this packet in this chapter, this section in functions. In this packet right here, the first part, we're going to be talking about parallel lines. So we need to be able to visualize two lines that never intersect. These are lines that they will go on forever and ever, and we denote these by putting arrows inside of the lines. Okay, that means that they're parallel. So let's go ahead and write down the word P-A-R-A-L-L-E-L. What's unique about them is that they have the same slope. Because they have the same slope, they're never gonna touch. They have the same pattern. Now I have a question for you. Are the following lines parallel? So this pair, this pair, this pair. Go ahead and look at them and see if you think any of them are parallel. First thing you should remember is if you want to know if they have the same slope, you look at the number in front of the x. And if they have two different numbers, then they are not parallel. So this is not parallel. But if they have the same number, it doesn't matter what number they have at the end, what's their y-intercept. They cross at two different points, that's what that means, but they have the same slope, so this is parallel. Now some equations, you're gonna have to do a little bit more thinking. In this one we have a 1, and this one has no number in front of it, but remember I've taught you guys before that if it doesn't have a number, pretend it's a 1, so these are the same sloped equations, so these are parallel, meaning they will never touch. They'll go on forever and ever and ever and never touch. Now, it's safe to assume that this pair looks parallel and this pair of lines look parallel, but you want to double check by counting their slope. And I've added some points on here for all 4 of these lines for you to double check. So we're going to count up 1, 2, 3, 4 over 1, 2. Now if we see the same pattern 4 over 2, then these two are parallel. So 1, 2, 3, 4 over 2. So these are two parallel lines. So then we'll just write yes. Parallel because slope is 4 over 2, which is just 2 for both. Okay, nice. Okay, now what about these over here? So they're going down, so it's negative. So let's count 1, 2, 3, 4 over 2. So negative 4 over 2. And then this one is 1, 2, 3, 4. Oh, nope. Looks like this is 5 over 3. So not parallel. Two different slopes. This is negative 4 over 2 does not equal negative 5 over 3. In this example, I'm asking you to graph two lines that are parallel with positive slope and then graph two that are with the negative slope. So I'm going to go ahead and draw a line anywhere around here. Let's see, here's one. And let's do this one over here. Oh, And you know what? Looks like I messed this up because it looks like I'm going down, but I don't think Mr. Martinez specified where to put the negative and where to put the positive. So we're going to say that these are the negative and then these are going to be the positive. So what's the slope of this one? So 1, 2, 3, 4, negative 4. I guess I got a thing over for 4s and 2s today. So I got to find another line that has the same slope as negative 4 over 2, which is just equal to negative 2 over 1, which is just negative 2. So that's our slope. So I'm going to pick another point, let's say one here. And if I want to create a line that's parallel to this one, I just have to make sure that it has the same slope. So 4 down, 1, 2, 3, 4 over 2. Just got to draw it. And so if these lines are perfectly parallel, they'll go on forever and ever in either direction and never touch. Now, what if we do one with positive slope? So I'm going to do one that's the easiest. It's just up 1 over 1. Okay, 45-degree slope. This is just positive 1. And I'm going to do another one. Just pick any point. Up 1 over 1. Okay, that's it. So both of these have a slope of up 1 over 1. So this is positive 1 slope. And this is negative 2 slope. Okay. All right, flip the page. Just make sure you go to the back. Determine if any of the following lines are parallel. So we got 3 lines here. We have no graph. That would have been nice. And then we have 2 lines, 2 equations. So let's see if any of these are parallel. So the way that we're going to do this is we need to use that formula that I made you guys use a lot last quarter. In the last chapter. It's y2 minus y1 over x2 minus x1. And so we're going to find the slope of these 2 points and these 2 points, these 2 points using this formula. So let's make these the x1 y1s, and then let's make this the x2s y2s. So all of these are going to be our y2s, x2s, y1s, x1s. So y2 is 1, so 1 minus 2 over 1 minus negative 4, so that's going to turn to a positive. So this is going to be negative 1 over 5, so that's a negative slope. Let's do the line B. So this is line A, B, C. So negative 2 minus a positive 1 over 1 minus negative 3. So that turns positive. So this is negative 1 over 3. So these don't have the same slope, so they're not parallel. Last one, negative 6 minus a minus a negative turns positive, so positive 5. And then 2 minus negative 3. So that's going to turn positive. So this is negative 1 over 5. So A and C are parallel, because this has a negative slope of 1 over 5, and this has a negative slope of 1 over 5. So they're the same. So A and C are parallel. Now what about these 2 lines? It's kind of hard to tell, so we want to simplify it. 2y equals 2x plus 10. 2y minus 2x equals 6. So this is line A. This is line B. All I have to do on this one is divide both sides by 2. So this cancels out and I'm left with y equals 2 divided by 2 is 1, so 1x. 5 divided by 2 is 5, so this is 1x plus 5. On this side, I have to do a couple things. I need to first get rid of this negative negative 2x. Notice how we have the y's and the x's on the same side of the equal sign, so we need to move these over there. So add 2x to both sides. This leaves us with 2y equals 2x plus 6. Then we divide by 2's, and we're left with y equals, again, 1x and then plus 3. So yes, these are parallel. Okay? They have a different y-intercept. This one it crosses at 5 and this one crosses at 3, but they both have the same slope, the same number in front of the x. Let's see, one last problem for this part 1, parallel lines. Again, we're visualizing lines that go on forever and never touch, okay? Now in this case, we already know the slope. The slope is 2, but let's see. We want to write an equation of a line that passes through this point and is parallel to this one. So we just need the slope. So since we have a point and we have the slope, we're going to use point slope formula. That was y minus y1 equals m times x minus x1. So we just got to put all the stuff in. So this 4 is an x, so that's going to be over here. So x minus 4. Our slope is a 2, so times 2. And then our y value is a negative 6, so we write y minus minus turns positive. So this is us plugging everything in. So let's simplify. So this is y plus 6 equals, multiply the 2 and multiply the 2, distribute. So 2x minus 8, because 2 times x is 2x. 2 times negative 4 is negative 8. And then we're going to subtract this 6. We need to get rid of that. So this is minus 6 to both sides. Cancels. Y equals 2x minus 14. So this line right here, we know for a fact that it's going to be parallel because it has the same slope, 2 and 2. And since we plugged in this point into the point slope formula, we know that this line not only crosses through this point, but is parallel to that line. So that's pretty cool. Let's see. Before we go on to this section, I'm going to go ahead and just open up a program called Desmos Calculator. All right, so here is the Desmos Graphing Calculator. I'm going to make these bigger so it's easier to see. I'm going to type in basically what we just did. So y equals 2x plus 8. Okay, here's the line. And we wanted a line that was parallel to 4 comma negative 6. And so that's over here. And so we ended up finding out that y equals 2x minus 14. And check that out. They cross. Okay? So basically, we were given this line, we were given this point, and our task was to find the equation of this line. So that's pretty cool. Like what we just did right now, that's really cool. You guys are going to get more time with the Desmos graphing calculator, so don't worry about it. But in the meantime, let's go ahead and flip the page, and now we're going to work on visualizing a different type of line. So parallel lines are interesting because they go on forever and ever and never intersect. And I don't know if we've talked about this in class already, but if you have two parallel lines on planet Earth and they hug the planet, they're going to come back to the same spot. And that's kind of like the thought between scientists, that if you have two lines that are parallel and they go off into space, into like the universe, eventually they're going to come back around, even though they're parallel and they're never touching. So perpendicular lines are a little bit different. They actually cross like the ultimate crossing point. It's 90 degrees. It's like an X, you know? And the 90 degree is important for you to understand because that's how you go from one dimension to the next. If you want to go between dimension 1 to dimension 2, then you have to create a 90 degree angle. And so you always have to create a 90 degree angle to hop to the next dimension. And that's why it's going to be important for you to understand the difference between parallel and perpendicular lines, because on the next set of math classes that I teach, I talk about dimensions, and you need to be able to understand being able to be perpendicular to create a new direction, a new dimension. So either way, let's just go ahead and hop into the packet. So now we're doing part 2, perpendicular. And perpendicular lines intersect to form right angles that are called, I guess I already gave you guys the answer, perpendicular. And these are non-vertical lines that have opposite slopes. So essentially one's going up, other one's going down. It's got to make a perfect X. And it's not just opposite slopes, but we call these the inverse. What do I mean by inverse? If you have a slope that's, let's just say 2/3, and I want the perpendicular line, like it's gonna have a slope where we swap the 2 and the 3. So the 3 goes on top, and then the 2 goes on the bottom. But remember, one slope goes down, one slope goes up. So if this was originally positive, the perpendicular slope is going to be negative. So not only do the numbers have to flip, but their signs have to flip as well. So there's a little bit more work to it. Are any of the following lines perpendicular? Well, all you have to do is look at the slope. In this case, they have the same slope. So these are not perpendicular. These are parallel though. Oh, it's a no. What about these? This is 1/2 and this is 2/1. So the numbers flipped, but they're both positive. So this is also no. Okay. This example, we do have 1/2. And then this is a -2. And remember, every single number that's by itself also has a 1 on the bottom. So 1 on the top, 1 on the bottom, -2, +2. So these are perpendicular. Let's do some work. Determine which of the lines, if any, are perpendicular. So we just have to count the slopes. 1, 2, 3, -3. 1, 2, 3, 4. Okay, what about this one? 1, 2. Up 1, 2, 3, 4. So these are not the same numbers. This is -3/4. This is 4/2. They do have 4s on opposite ends, but this is -3 and that's +2. So this is not perpendicular. So I'm assuming this one has to be perpendicular. So let's go ahead and count. So 1, 2, 1, 2, 3, 4. So this is 2/4 equals 1/2. And this is 1, 2, 3, 4 -4/2. So this is 2/1. And this is -2/1 because we're going down 4. So this is -4/2, which is equal to -2/1. And then this is 1/2. So this is yes, they're perpendicular because the 1 went on the top, the 2 and the 1 flipped, and then this one's negative and this one's positive. All right. So let's draw 2 sets of perpendicular lines. I think I'm only going to draw one. I'll have you draw another one, but I'm going to pick something simple. So let's see. Up 1, 2, 3/1. Let's draw the line. Okay. I need to now, if this has a slope of 3 over 1, the perpendicular slope is going to be 1 over 3, but it's going to be negative. Okay? So I'm going to go ahead and draw two points. Let's draw this one. And now I have to go down 1 over 3. 1, 2, 3. And if I draw this line, that should be perpendicular. So I have to put a box to show that it's a perfect corner. Okay, you can turn it to see that it is. So again, whatever slope you pick, you got to flip the numbers and then flip the positive to minus. Okay, so this one was positive, this one was negative. Okay, so some similar problems. We want to determine if any of these lines, okay, and we already know what to do, right? We need to know if any of these lines are perpendicular. So I'm going to use the same formula we did last time. So it's y1 minus y2 over x1 minus x2, which just really means we subtract the y's and we subtract the x's. So the x's are the ones in the beginning, and then the y's are the second number. Okay. Now I'm going to go ahead and make these the 1s and these the 2s. So I'm just going to do y1 is negative 2. So negative 2 minus 0 over 1 minus 3. So this is negative 2 over negative, oh wait, excuse me. What's 1 minus 3? That's negative 2. So a negative over a negative equals a positive. So this has a slope of 1. 1 over 1. Let's see, B. 4 minus 6. 1 minus 4. Negative 2 over negative 3. This is just minus over negative is positive, so this is just 2 over 3. Okay, so nothing perpendicular so far. Let's do the one more. So 3 minus 4 over, sorry. 1 minus 4. 3 minus 1. So this is negative 3 and then 2. So these two are perpendicular. See how we have a 2 and a 3, 2 and a 3, but they're flipped, and then one's positive and one's negative. So these are perpendicular. So B and C are perpendicular. Okay, line A and B. So this is 8x minus 6y equals 12. This is 3y equals 4x plus 6. I need to get rid of this 8x, so subtract 8x to both sides. This leaves us with negative 6y equals negative 8x plus 12. We then divide by negative 6 to get rid of this negative 6. We're left with y equals negative is positive, so this is 8 over 6x plus 12 over 6, but this is going to be negative because that's negative. 8 over 6, this is 4 over 3. Okay, so just kind of keep that in mind. That's 4 over 3. That's our slope, and it's positive. So where you need a slope of negative 3 over 4. So let's see if that's what we get. All we have to do is divide both sides by 3. So we're left with y equals 4 over 3x plus 6 over 3, which is just 2. So it's not these are not, they're actually parallel because look, they have the same slope. They're not perpendicular. So not perpendicular. Or we can just use this. That also means perpendicular. All right, now we could use Desmos to graph these because we want to see a line that's perpendicular to a point that goes through there. Excuse me, an equation of a line that passes through this point but is perpendicular to that. So if I want something perpendicular to this, I just have to flip the slope. So instead of 1 over 2, this is going to be 2 over 1. And since this is positive, this is going to be negative. And this is just equal to -2. So that's our slope. So we have a slope of -2. And we needed to go through that. So we're going to use the formula y minus y1 equals slope times x minus x1. This is a point slope formula. So we got the point, we got the slope. So just replace it. This 2 is an x, this 6 is a y. So y minus the y1, so that's a 6. Slope is -2. X minus the x, that's 2. So we're just going to go ahead and simplify. Y minus 6 equals, distribute. -2 times x is -2x. -2 times -2 is positive. Negative, because it's a negative times a negative is positive. And 2 times 2 is 4, so positive 4. And then the last thing we got to do is we got to get rid of this -6. So we'll add 6 to both sides. Cancels, and we're left with y equals -2x plus 10. So this line right here will go through this point, as long as we did our math correctly, and will be perpendicular to this line. So let's go ahead and see if we can double check our answer by going on to Desmos. And here's Desmos calculator. Let's get rid of all of these. Let's start over fresh. Zoom out a bit. Our first equation was 1 divided by 2x plus 4. And we wanted a line that went through 2 comma 6. Okay, let's go ahead and label it. There we go. So we want a line that's perpendicular and it goes through that point. So we found out that it was y equals -2x plus 10. And look at that. It goes through this line, that point, boom. This is a 90 degrees, so this is perfect. We did a good job. Pretty good. So let's go ahead and go to the next section. Now that we were able to confirm that we did this correctly, we're going to flip and we're going to do part 3, correlation. We're going to talk about scatter plots, which are used to describe data, information. But really what we want to know, what kind of correlation does the data have? So correlation is a relationship between the data sets. If we have a bunch of dots that are all going up, we call this positive correlation. But we have a bunch of dots that are going down, call that negative. And if you get dots that are all over the place and you can't really seem to draw like a straight up or down line, we call this no correlation. But before we get started, I just want to see if you guys know how to plot points. Obviously, this is a positive correlation, and this is also a positive correlation. I'm sure you guys can tell these are all going up. Okay, it's like a straight line almost. See? Let's go ahead and find the missing points. So the first number is an x, the second number is a y. So if the first number is a 0, that means that we don't move. And the only point that we see that is on the straight line is this one. So you go up 1. Okay. This one is asking for something that went up 3. So what went up 3? 1, 2, 3. This one right here, and that's a 1, 3. So 1 comma 3. This one's saying the x moved 3 spaces to the right. So 1, 2, 3, boom. So 3 and 4. And this one, something that went up 4. So there's actually 2 of them. So we can either pick this 2 or we can pick that 3. But let's go ahead and pick 2 because technically I think we already did that one. And then we got something that went up 7. So it's 6, 7. 6, 7. And then this is 7 to the right. Up 6. Okay. I'm not going to do all of these for you. I'm expecting you to do these yourselves. And then these are easy to answer too. Part 2. Answer the following questions using the scatter plot. So this is our scatter plot. It's obviously a positive correlation, is going up. Price of a processor with a speed of 14 gigs or gigahertz. So 14, boom. What is that price? 14 would be, if this is, that means this is going up 50. So plus 50, plus 50, plus 50. So this is $400. So $400 for a processor with the speed of 14 gigahertz. What about a processor's cost of the processor speed of 350 units? So 350, there's actually 2. It's either 11 or 12 gigahertz. Okay. And obviously we already talked about this, that what trend seems to happen as the speed increases. So as the speed of the processor, excuse me, this is one of my hairs. Speed of the processor increases, so does the price. So that's what you would write. Price also increases. Flip it over. So let's make a scatter plot and describe the correlation. So this doesn't say what it's about. That's interesting, but it might be frequencies. I recognize these 2 frequencies, but I don't recognize the rest. So either way, x goes up in 5s. So we can say this is 0, 5, 10, 15, 20, 25, 30, and 35. And then these go up, they're between 89, so like 100 and 700. Maybe we can just say 100, 200, 300, 400, 500, 600, and 700. So this is about 678, somewhere around here. So I'm going to put a dot there. 10 is 603. 15 is 528. 20 is 432. 25 is 313. Try to put your best spot. And 30 is 211. And then this one actually goes underneath. So yeah, this looks like it's a downward trend, and it almost looks kind of smooth, like a curve. I'm not sure what this is. This could be like the distance of a rocket over time. So it's kind of hard for us to label this, but definitely a negative correlation. Okay. Do you guys think you can do this one on your own? It looks like the days are about the same. So 0, 100, 200, 300, 400, 500, 600, 700. And then this is in inches, between 20 and 140. I think it could probably do 20, 40, 60 increments of 20. So that's me helping you guys out. Yep, it's gonna go above just a little bit. So 700 is going to go somewhere like around here. So it's just a little bit off the paper, but go ahead and plug these in on your own. You might want to label this days and inches. And you just have to find out if this is going to go up or go down. So if it goes down, it's negative, and it goes up, it's positive. All right. So what do we have to do here? Part 4, stories. Follow along with the decimal stories and pick 4 of them, graph, and explain the lines. Okay, or it should really say explain the graphs. So in this part, as a class, we're doing a decimals lesson, and there's all these different graphs, and once you're done with all the graphs, I want you to graph them on the paper and explain them. So I'm going to pull up right now the decimals actual lesson that we're doing. So let's go ahead and do that. So this is already the second slide. You can go back to the first slide, but we talked as a class what are the different measurements that are changing over time in this video. And so we said that it's a guy's height. We talked about he's moving, and we're measuring time and maybe even speed. There's a lot of different things going on in this video. But what's important is this. So we're actually going to sketch in time and the height of the waist of the guy. So we already did this as a class, but let's show you. So the height of the guy's waist. So I'm just looking at his waist. Straight down, and then stays like that, and then slides. Okay, so maybe mine's not that great, but let's look at the answer. Okay, we're gonna watch the answer. So not too bad. So we can tell it's a straight line, stops, dips. So my dip was a little off, and it should straight line, and then all of a sudden, boom, he falls down. Oh, and then he gets back up. Okay, so there's a bunch of stuff going on here. So he's just standing. He's going up the stairs. Sits down. Takes a break. He's contemplating his life. He's kind of scared, and then he goes down the slide and then gets back up. Okay, so that's one graph that you guys can draw. Let's take a look at the next one. So water pouring in. We're just going to go ahead and look at the answer. Oh, actually, they're sketching, sketch. We're going to look at the answers over here. So let's watch the answer. Okay, so water being poured. You can see water being poured. But then they pour even more. And so there's some stuff going on. So 1, 2, 3. And there's actually not 4 things that happen on here. It's just 1, 2, 3. Let's take a look at the next one. Amount of eggs in the carton in time. Most of our graphs are in time, especially because we're watching videos. So there's 5 eggs. Then it went from 5 to 4 because he took it. Notice there's a gap here. Gap. This is because this is a discrete graph, meaning we can't have anything in between, and we've learned about this already in class. So this is discrete. It's either 5, 4, 3, 2, 1, 0 eggs. So we had 2 eggs for the longest, but that's what that is. And then there's another one. There's actually like 2 more, and you get to pick which ones of these you want. So this is the distance from the camera. So the guy's going up. He's getting further and closer to the camera, further and closer because he's walking around, and so that's him getting further. So this has a lot of stuff going on. Let me go ahead and close this. On this paper, you're basically going to copy the 4 graphs that you want, and I just kind of explained all of them right now. I did my best. It was kind of quick. But in class, I'm telling you to label label, and do your graphs, okay? So I don't know if you can tell which one this is. Okay, this was the slide. Then there was the one with the water, so it goes up and then boom, lots of water, and then then it goes back again. And this one should be parallel to this, so because those were the ones that were consistent. So I didn't draw them exactly parallel, but something close. And then you're gonna go ahead and write what we see on here, even though I didn't give you guys that much line, but just go ahead and explain them. You can do the eggs graph or either of the carousel ones, but the most important thing is the backside. This is where you are gonna come up with your own story that has at least 4 different parts. You're gonna label the 4 different parts on here, and you're gonna write A, B, C, D, and you need to have something on here and where you describe what happened here, what happened here, what happened here, or C, and then D, the 4 different parts. And it could be anything. It could be a car, it could be someone's money, there's a lot of things that we talked about in class. You come up with your own. I've seen the coolest things. I've seen people talk about like amount of points on a team, or how much somebody's winning and losing on a football team, how much money someone's made, and then they lost, and then they made, and they're like, okay, well, this is us spending money to like buy a big machine. Then the machine builds all these hats. We sell the hats, we make more money, then we buy a bigger machine, or whatever. This is up to you to come up with something interesting to create a cool story. And again, we're visualizing a graph and trying to understand what it looks like. Whether you're given an equation, a graph, points, a table, a scatter plot, which is something that you guys learned about this week. Our main vocabulary words are parallel, perpendicular, and correlation. And again, if you need any more help, just ask me for help. You guys can come in the morning, after school, or during lunch. Lunch is probably the best time for you and for me. But you guys can also ask me for help during class. But hopefully this video has been helpful for you. If it has, go ahead and give it a like, thumbs up, and I'll see you guys tomorrow in class. All right?